Hello everyone, my name is Eduardo Divo and I am the chair of the Mechanical Engineering Department, and on behalf of the faculty of the Mechanical Engineering Department I want to give you an official welcome to the fall 2020 semester, and I want to give you a welcome to the ES 305 Thermodynamics course. I am going to talk to you during this session about some administrative issues with the class and how we're going to be conducting the class. Your instructor record might be different for your section. It might either be Dr. Starlaci, it might even be Arkadas, Vijay Duarswamy, or Burak Sankakhtar, all three of them PhD students in the department. But regardless of your instructor record these are going to be the general instructions for conducting this class this semester. Again, my name is Eduardo Divo, and you might actually see me during the semester through the video lectures, because I've recorded these lectures over the years. I've been teaching thermodynamics for about 30 years, and I recorded a set of 25 lectures with the same content that you're going to be exposed to during the semester. For the state system. I used to work for the Florida state system, university system, and you will notice that the lectures have a different code. It doesn't say ES 305, it says EGN 3343. EGN 3343 is the state code for thermodynamics, whereas in Riddle is ES 305. It's a specific code. So we are going to be conducting the class through Canvas. During the fall 2020 semester. Everything is going to be posted through Canvas. All resources, materials, syllabus, lectures, and so on will be posted via Canvas. All communications are going to be performed via Canvas as well. And let me give you a little flyby to show you what your Canvas site will look like. Right now it's unpublished, but it's on the start of classes on Monday. You will see this class published and on your list of courses. So if you go to Canvas and go to your specific section, which should appear on your list of courses once this class is published, you can go to Modules, and within Modules you'll see that everything has already been posted. Some of it is not actually visible to you, only the module that contains the syllabus and calendar, the module that contains the tables. The tables are very important in thermodynamics because that's how we connect the properties of different substances and gases. And the course is going to be divided into part 1, part 2, and part 3. Each part with a different set of lectures. All these lectures are on YouTube, but I've actually placed links to these lectures here in those modules. And culminating with 2 assignments in an exam. So part 1 goes from lecture 1, which is this one, all the way to lecture 9. And it has assignment 1, 2, and exam number 1. The due dates for those assignments and exams are already posted on the syllabus, and they're already actually synchronized here with these modules. Part 2 contains lectures 10 through 19, and it also contains assignment 3, 4, and exam number 2. Those, again, are already synchronized. The deadlines, the release date, and the deadlines for these assignments are already synchronized with these tools in these modules. And the last part of the semester is part 3. It contains lectures 20 through 26, and it contains assignment 5 and 6, as well as exam number 3. As you can see, there's no final exam. There's 3 exams corresponding to the 3 different parts of the semester. Also very important to note that part number 3 is a little bit longer than part number 1 and 2, because part number 3 is where all the concepts of open systems and second law thermodynamics and entropy are actually introduced. So let me show you the syllabus once you click here on syllabus, but I'm going to just open the PDF file. I already have it open. All it will give you access is to a PDF file with the contents of thermodynamics, starting with the catalog description. As you know, this is a 3-credit-hour class. This course focuses on the concepts of heat and work and their transformation as governed by the first and second law of thermodynamics. Properties of pure substances, including liquid, vapor, and ideal gases, are discussed, and classical thermodynamics are applied to both closed systems and open systems by incorporating entropy balance. Conventional power cycles and refrigeration cycles are introduced towards the end of the semester. There are some course objectives that have to do very closely with the description of the course. This particular section, section 2, is going to be taught by Dr. Gaetano Starlaci, as well as section number 3 and section number 8. As I said, this also applies to additional sections. This same structure applies to additional sections of these course. In this particular case, the lectures will be on LB 369. This is for section 2, but obviously when you open your specific syllabus, you'll find where your lecture is going to meet. It is also going to meet in split format because there's more students enrolled in the section, for all the sections, than the number of students that can be held in the room capacity. And therefore, the professor is going to coordinate with you before the start of classes on Monday, so to figure out how to break up in cohorts or groups. So you're going to get to see the professor live every week, but it might be on Monday, it might be on Wednesday, it might be on Friday, depending on your last name or whichever way the professor decides to break up the class in groups. The textbook that is going to be used is the classic Fundamentals of Engineering Thermodynamics by Moore and Shapiro, Bettner and Bailey. This book has been around for a while. It's a 9th edition, and there's also an electronic book that you can have access to. There's some very good references, and these are obviously not the only 2 references that work for thermodynamics. Some specific learning outcomes, but more importantly, the topics that we'll cover: concepts and definitions, first law for closed systems, properties and property relations, first law for open systems, second law, the concept of entropy, vapor power cycles, gas power cycles, and refrigeration cycles. In addition, there's a few details here as to what the components of these classes are. These are for assessment and accreditation purposes, and which one of the program outcomes are actually satisfied by these particular course. And in particular, this course satisfies program outcome number 7, an ability to acquire and apply new knowledge as needed using appropriate learning strategies. As I mentioned already, the course will be divided into 3 parts, each one culminating with 1 exam. Each exam is 30% of the grade. There's no final exam. Exam number 3 is considered the final. And the homework assignments are all together. All 6 homework assignments constitute 10% of the grade. Now, 10% of the grade might not seem like much, but it's actually a full letter grade. And it's not only important because it is a full letter grade, but it's also important because each of these 2 assignments on every part actually give you a good idea, a good indication of what the exam is going to be. So it is very important that you work on these assignments so as to know what to expect for each of the exams that are coming at the end of these parts. There's a very standard grade distribution. If you score more than 90.00, you get an A, and so on and so forth. Anything below a 60 will be considered an F in the class. There will be assignments already pre-scheduled, and I'll get to that when we look at the calendar. And more important, comments here about specific aspects of excusals and justifications, computer usage, library usage, course policies. Again, this semester will be very unique. The circumstances are different. Everything will be done in a semi-presential, semi-remote format. Some of the classes are going to be taught online. Some of the classes are going to be taught live. All the lecture components, all the lecture material will be posted on Canvas, and it's up to you to coordinate with the instructor to watch these lectures prior to coming to the live classes. So you can concentrate on the live classes, on the actual problem solving and learning and implementing these concepts. The calendar for the semester, for the fall 2020 semester. See, these are the topics that are going to be covered week by week. As you know, after Thanksgiving, there will be no classes. It's basically study week from November 30th to December 4th, an entire week for studying, and then the final exams right after that. However, I've already noted that in this particular class, there's no final exam scheduled during the week of finals. The final exam will be done on the Monday right before Thanksgiving. So as you can see, as you progress through the topics, they'll culminate with an assignment, with 2 assignments, and then an exam on that same week that the assignment 2 is actually due. Depending on whether your cohort meets on Monday or Wednesday, your exam will be on Monday or Wednesday, with the exception of exam number 3, which will be fully online. Again, the submission for these assignments will be done online through Canvas. They've already been pre-scheduled. Notice that assignments are due on a Monday, and they are posted the Monday before, so you have an entire week with the assignment before it's actually due. In the case of the exam, whether the exam is live or online, the exam will be posted the day of the exam. A few of the holidays for the semester have been eliminated. That includes Labor Day and fall break. So basically, we're only observing Veterans Day and Thanksgiving week. Study days, as I mentioned, are from 11:30 to 12:04, but those are not going to be relevant to this class. So this is what I wanted to cover. I hope this gave you a good introduction for what to expect in this course, ES 305 Thermodynamics for the semester. And again, on behalf of the faculty of the Mechanical Engineering Department, I want to welcome you to Embry-Riddle for those of you who are new, or I want to welcome you to the fall 2020 semester. Again, this class is an engineering sciences class. It's administered by the Mechanical Engineering Department, but many people from many different majors actually are taking this class. Most of you from aerospace engineering, but people from mechanical engineering and even from electrical or civil engineering can take this class as electives. So thank you very much, and we'll see you during the semester. Goodbye.